I'm gonna need you to pull out the world's smallest violin because I'm about to tell you a sob story. See, 2 days ago I spent the entire day writing scripts and recording videos for this channel to help you guys learn your science for your exams. And then when I went to edit it, I discovered my audio was terrible. So here I am, rushing some footage together because I want to make sure that I can at least help you guys with your exams. Starting off with the basics, we're going back to the history of the atom. Alright, enough of the sob story, let's get on with it. So, the history of the atom, we're taking you way back, 2,500 years ago, back in ancient Greece. 2 Greek philosophers named Democritus and Leucippus. Leucippus? One of them. Anyway, now these 2 philosophers, they had the idea that if you had an object and you cut it in half, you had half an object. And if you took one of those halves and you halved it again, you had a quarter. And then you take the quarter and cut in half, you've got an eighth. Well, what happens if you keep cutting until you can't cut anything anymore? Well, they wanted to know what you would call that thing that is uncuttable. And that's where the Greek word atomos comes in, or what we now call atoms. So these guys had the idea that an atom was something that can't be cut anymore. It's indivisible. And that's a pretty good idea. And to be fair, it hung around for a while, like a long time. It hung around until 1808.
2,000 years later.
When John Dalton came along and theorized that atoms were the shape of spheres. Just like the shape of this basketball. John Dalton said that atoms of the same element were absolutely identical, and that atoms of different elements varied in size and in mass. And it took about another 90 years until the next big change by J.J. Thomson, who came up with the plum pudding model. Now, J.J. Thomson's model said that the entire sphere itself was all positive, but randomly spread out inside there were lots of negative charges, which he called electrons. Now, I'm guessing J.J. Thomson was a foodie because he called it the plum pudding model because he said those electrons randomly spread looked like the plums inside in that pudding.
Yeah, boy.
Now, just over a decade later, a New Zealander called Ernest Rutherford, who was a university lecturer in Manchester at the time, came up with an experiment that helped prove most of the mass in an atom was in the middle. In this experiment, Ernest Rutherford fired alpha particles at a small sheet of metal foil. If J.J. Thomson's plum pudding model was correct, all these alpha particles should just pass straight through. And to be fair, the majority of them did. But something really random happened. Lots of the different particles started getting deflected in different directions. Now, if J.J. Thomson's model was correct, that shouldn't have been happening. And they did this experiment over and over and over until they realized there was something in the atom repelling those particles to change its direction. And that's where Ernest Rutherford theorized a nucleus. He theorized that all of the positive charge was in the middle of that atom and that the rest of it was just like your love life. Empty. And Ernest Rutherford's experiment became known as the gold foil experiment. There was one problem though. Based on his calculations, all those negative electrons should collapse in on that nucleus. So something wasn't quite right. Here enters Niels Bohr, who created the model that you guys would probably end up drawing in your exam. He joined Rutherford in his experiments and theorized that the electrons didn't just exist in this space, that they were at different levels outside of the nucleus. And he called those levels shells or orbitals. And this meant that the electrons couldn't collapse in on the nucleus anymore. And that's the model that you guys will probably end up drawing in the exam. No real changes happened after that for about another 20 years because of a little thing called, the war. But in 1932, James Chadwick added to the theory by discovering the neutrons and saying that there was something that had no charge inside that nucleus, but that did have mass. And that's as much as you guys need to know for the GCSEs. Now, there are a couple of theories that exist beyond this, but you guys don't need to learn that for your exams. If you are doing Leaving Cert or A-level chemistry, I will put a video together for you on those. If you enjoyed that video, make sure hit that like button, click subscribe, and make sure to ring the bell as well for notifications for when I bring out a new video. And let's pass these GCSEs.